I am the Big Robo Neuroscientist, and this short animation will present a neurochemical theory for the cause of migraine headaches and a very unique treatment. Let's begin what we believe with that migraine headaches are problems with your brain's electrical system that are not explained by nerve fibers, myelinated, meaning insulated or not, such as popularized by some theories. Instead, we believe that the source of migraine headaches is a problem with the brain's neurochemical battery, which provides the electrical signal that an electroencephalography can detect and are used in sleep studies. What is the source of these electrical pulses? For the answer, we must travel back in time to 1952 England and visit the lab of Alan Hodgkin and Andrew Huxley with their Nobel Prize-winning work of measuring the electrical signal generated by a giant squid. Hodgkin and Huxley theorized that sodium ions and potassium ions were traveling across the cell membrane to generate the electrical signal that was detected by the voltage inputs of their oscilloscope. Your neurologist or medical doctor knows this phenomenon as the action potential. And the important concept is that your brain's electrical battery needs both sodium and potassium ions, similar to an electrical car's lithium battery, to work well. Let's take a look at the periodic table of the elements. That was first recognized by the Russian chemist Mendeleev in the 19th century and even today. In the Russian Federation, it is still referenced as the Mendeleev table. The most important elements in your brain's battery is sodium and potassium ions, which is found on the periodic table in the leftmost column 1A. Let's return to present-day Germany and observe a very powerful magnetic resonance imaging made by Siemens Healthineers division with a potassium-39 coil. Their K39 scan shows that potassium is found primarily inside the cell, at resting equilibrium state with sodium being found outside the cell. With a nonspecific membrane, such as an unfunctionalized polymer, the potassium ion concentration inside the cell will be identical to the potassium ion concentration outside the cell. And likewise, this same phenomenon will be true for the sodium ion concentration. Thus, the electrochemical potential or measured voltage will be exactly zero as shown on the voltmeter. However, a cell membrane is very ion-specific with lanes of active transports for the potassium ion from outside of the cell to inside the cell, as well as the sodium ion selective movement in the opposite direction from inside the cell to outside the cell. The net effect of these two cation transportations are that 145 millimolar of potassium exists inside the cell while there are 4 millimolar outside the cell. Similarly, but in the opposite direction, a sodium ion concentration of 145 millimolar exists outside the cell, while 10 millimolar of sodium resides inside the cell. Due to these differences, the electropotential voltage is about minus 70 millivolts, as shown in the voltmeter. However, to provide energy to any muscle in the human body, the sodium-potassium energy cycle, known in the medical literature as sodium-potassium ATPase pump, must be employed with its 6 biochemical steps. 1. Sodium binds to the membrane pump. 2. Pump adds phosphorylates, forming sodium phosphorylate and reducing ATP to ADP. 3. Once the high-energy link is activated, sodium is ejected outside the cell. 4. Inside the cell, potassium binds to the phosphorylate ion. 5. The cell membrane is dephosphorylated, meaning that the phosphorylate is lost. 6. Potassium returns to the internal cell membrane. The cell is ready for another energy cycle since the original configuration is restored. The important lesson from the sodium-potassium ATPase pump is that every neurochemical signal requires this energy for transmission. We have always assumed that there is sufficient amount of sodium and potassium ions to produce the neurochemical electrical signal. As previously mentioned, sodium is easily replaced, since the vast majority of sodium is outside the cell. Approximately 97% of potassium resides inside the cell, and once it is lost via sweat, there are localized problems, such as a marathon runner who starts out the 26-mile race in the best of shape. At the end of the marathon, this very same runner can hardly walk because the potassium is lost from sweating. That's why they give out free bananas, for their potassium content. So, we believe that a big problem with migraine headache sufferers is that there is not enough potassium in the brain. Although potassium tablets appear to be a solution, very little potassium will find its way to the brain, as it must first be digested, then transported into the blood via the heart, and then much of it will be excreted in the urine, so a minimal amount of potassium will cross the blood-brain barrier. Additionally, potassium has a very tight specific range in blood, and the heart is regulated by the amount of potassium in the blood. As seen by the weightlifter Eddie Hall, a strongest man competitor, overdosing on potassium tablets can be very dangerous. So, we have developed a protocol to add potassium to the brain in a safest way. The first lesson to understand is that the brain's primary liquid surrounding the brain is the cerebrospinal fluid and not blood. In essence, blood is filtered to produce the cerebrospinal fluid, which is 99% water through the blood-brain barrier. From medical scientific literature, we can clearly see that sodium is essentially the same and identical value found in the cerebrospinal fluid as found in blood. This is not true with potassium, which shows a marked decline in the potassium concentration in the cerebrospinal fluid when compared to the blood. With our patented protocol using our patented cream, we will be supplementing potassium ions directly to the cerebrospinal fluid, and adding these potassium ions will induce a naturally sleepy state. So, the best time to follow the method is right before bedtime. Also, the published research of Dr. Jeffrey Iliff and Dr. Migraine Nettergaard shows conclusively that the cerebrospinal fluid does not move appreciably in the brain until a person falls asleep. The first step is to open the tube of Big Relief with +K+. Squeeze the tube, placing a little dab of our potassium-enriched cream onto your two biggest fingers. Then, with your cream-filled fingers, rub the cream onto the back of the neck. It is important to wash your hands after placing the little dab on the back of the neck, so that there are no residual cream and the danger of placing the cream in your eye. Mexican surveys of 23 migraine headache sufferers, 80% stated that our protocol totally eliminated their migraine headaches. Additionally, almost 90% of our study participants stated that their sleep quality improved dramatically. Finally, since I am an American chemical engineer and former marathoner with an inorganic background, I believe that this chemical science is the strongest theory and treatment for migraine headache sufferers. So, I invite you and your neurologist or medical doctor to review this low potassium theory, blocking the action potential, and this unique treatment to supplement potassium ions in the cerebrospinal fluid. Here is my contact information.